Hello. This video is about finding the dot product of two vectors. Our essential question is, how do we determine the dot product of two vectors, and how can we tell if the two vectors are orthogonal? First thing we need to do is start out with our dot product. Dot product of u equals u1 comma u2 and v equals v1 comma v2 is u dot v equals u1 times v1 plus u2 times v2. So you're going to end up with one singular value for the number. Properties of the dot product, where u, v, and w are vectors and c is a scalar. First property, u dot v is equal to v dot u. Property number 2, 0 dot v is equal to 0. Third property, u dot v plus w is equal to u dot v plus u dot w. Fourth property, v dot v is equal to the magnitude of v squared. And the fifth property of the dot product is a scalar c times u dot v is equal to c times u dot v, or u times u dot c times v. So go ahead and pause, finish copying these, and we'll move on to some examples. First example, 4, 5 as our first vector, dot 2, 3 is going to equal 4 times 2, so the first one times the first one, plus 5 times 3, the second one, times the second one. So figure out what the products are. 4 times 2 is 8, plus 5 times 3 is 15. 8 plus 15 is 23. So our dot product for the first example is 23. Next example, the vector 0, 3 dot the vector 4, negative 2 is going to be 0 times 4 plus 3 times negative 2. 0 times 4 is 0. 3 times negative 2 is negative 6. When I add those together, I get negative 6. Go ahead and pause, finish copying these, and we'll move on to the next example. The next example, determine the dot product of u dot v for u equals 2i minus 3j plus k and v equals 4i minus 2k. First thing we have to do is write out our vectors in bracket form. So I have 2, comma, negative 3, comma, the number in front of k, remember, is a 1. So we're going to be dotting that with 4, comma, there's no j term, so there's a 0j there, comma, negative 2 for the k value. Now we go through and do the individual multiplications. So we have 2 times 4 plus negative 3 times 0 plus 1 times negative 2. Multiplying, we get 8 plus 0 plus negative 2, so we get a dot product of 6 when we add those together. Okay, go ahead and pause, and we'll move on to our last two examples. Next example, two vectors are orthogonal if their dot product equals 0. In other words, u dot v is equal to 0. So in this example, we want to determine if the following vectors are orthogonal or not. So the first thing we're going to do is do the dot product. So we have 2, negative 3, dot 6, 4. So we're multiplying 2 times 6, and then adding to that negative 3 times 4. 2 times 6 is 12, and negative 3 times 4 is negative 12. 12 plus negative 12 is 0, so u and v are orthogonal. And the word orthogonal means perpendicular. It's just a fancy way of saying perpendicular. We use the term orthogonal when we're talking about vectors. So last example, we want to determine if u and v are orthogonal or not. So the first thing we're going to do is write it as a vector point. So we have 3, 2. And we're going to dot that with 6, negative 1. So we'll go ahead and do our dot product. 3 times 6, so the first times the first, plus 2 times negative 1, the second times the second. Now we're going to figure out what those are. We get 3 times 6 is 18, 2 times negative 1 is negative 2, and 18 plus negative 2 is equal to 16. So u and v are not orthogonal. And the reason for that, because u dot v is not equal to 0. Let's go ahead and finish copying down your notes, and then we will work on our problems. Thank you, and have a great day.